What's your issue now, Leo?
I'm just looking over it one more time. So do I have to make another array within here?
Yes,
Or
yes,
yes.
yes. So if somebody is throwing to you a ball, you will adjust your hand to receive the ball. If somebody is throwing to you a box, you have to adjust your hand and make it wider to receive the box. So everything that the function is returning to you is like somebody is throwing something to you. You have to adjust. If you're throwing in an array or a box, so you have to adjust your hand to receive that. So that is what you are doing now. Okay, that's interesting. Excellent. Mm-hmm.
Oh yeah, I have to.
Exactly, yes. So the point here that um, the programming language like Java, they first, okay, so they don't see this portion. This portion is inside an if statement. So it means that this if statement is actually not so if this is not a true condition, it means that this portion will be executed, right? So it means that
Yes.
there is a big chance that this you will try to return an uninitialized array in this case. So there is two choices that you can do here. You can try to assign this. So you can try to move this 40 and 41 before the return statement. So it means that always you will guarantee that this will have a value. And if it is full, so if it is full or not full, it will still have a value from front and rear. Here, inside here, if the condition is true, you will modify the values for the rear and the front. If it is, if it is not full, you will modify the rear and the front. Here, you will not modify anything, and the front and rear that you already passed in will be returned also. So in any condition, it will be returned. Do I need to repeat what I said more, or?
No, I see.
Okay. Okay. There is one more thing that we can add here. So actually, these two, since you already moved it here, can be actually combined to say front and rear. So this means that this can be, you just remove the semicolon, put that here, and you can even comment these two lines. Did you get what I'm trying to tell you?
Yeah. So
Can you run now? Does it work?
no, it keeps detecting it as empty.
I mean, okay, the logical error, yes, it's working. So we have to troubleshoot. Is it the output of the queue is the one that needs some modification from us? So we are able to give. So I would like you to print. So now when you are adding something, you're adding to the front and rear. You are adding something to the queue, right? I would like you.
Yes.
I would like you to come here and actually print what is the value inside front and what is the value inside rear. We would like to see, because like this, we are not sure if everything is working as it should be. Put them in one line, print the front and put a dash in between so that we can somehow. Yes, okay, good. So you see, you have been adding actually to the queue. You have been enqueuing a lot, right? But still the front pointer always pointing to -1. This dash, so next time put spaces in between the dashes, but yes, and after it, yes, perfect. You can, now I want to understand from you, is it the front pointer should be always pointing to -1? It should not be affected? What do you think? So its initial condition is -1. The rear become 4. It means that you already inserted 1, 2, 3, 4, or even 5 times. So can I?
Because it says, yeah, it says it's empty if front equals
Yes, that
-1,
is
so
the
it has to
reason that is
change
always
for.
printing for you a queue is empty, right? Because it will look always the condition of is empty is to always check the front is -1. And even though here you already added how many times? You already added enqueued 5 items inside the queue, and still the front pointer is pointing to -1. This is our queue, even though it is a linear queue. This is the front, and suppose the rear is pointing to here. But initially, both of them, the first time you add something, the front is here and the rear is here, and both of them is pointing to -1. This means that they are not pointing to the queue anyway. So when you first add to the queue, it means that if you look at your code inside the Enqueue, you're always incrementing the rear, but you never touched anything regarding the front, even though you're already taking it as an input, right? Have you done any operation on the front?
No.
Okay, my question to you, when do we touch the front and when we touch the end? So when we do some operation on the front and when should we touch the rear? We have two operations, Enqueue and Dequeue. So we know the Enqueue is adding to the rear, right?
Yes.
But there is only one time we need to touch the front inside this code
the
here.
first time. Yeah.
Yes, yes, exactly. So the first time we have to add +1. If it is -1, if it is not, then we will not touch it.
Do I have to just put another if inside of here? Or?
Yes, yes, yes. So what do you think now? There is something coming out. It's not empty anymore.
Yes.
Okay, state of the queue, second, third, fourth, fifth, third, fourth, fifth. It seems that
I have a Dequeue loop here.
okay, so this is the Dequeue portion. Okay, so it means that it seems that here, state of the queue, you already inserted first and second and third and fourth and fifth, and this is the Dequeue that you're trying to do, right?
Yeah, it's the homework.
And it seems that it works.
Yes.
Okay, good, good, good. Let me see. Okay, now I want you, after you do the Dequeue, please copy also that line and put it here. I would like to see the values.
But it doesn't say queue is empty here, even though it's okay. So there might be a problem there.
We need to check it.
Yeah.
So there might be some adjustment that is need to be done on the Dequeue portion, because
So, because if empty is now is if front equals -1.
So first of all, the item class that you are using here, you are using it, and it only got the get front. But when you Dequeue, actually, you have to also, when you are passing the front and rear, so when you're Dequeuing, you are adjusting the front, right?
Yes.
But so yes, it is true that will be, when you Dequeue, you're only adjusting the front, but it is the same like when you Enqueue, you was passing the front and rear, and you adjusted the front only in certain condition, which is when it was -1, which means that you inserted for the first time in the queue. So here, when you reach the end of the queue, there is also a certain condition that you have to return back the pointers to this. So it means that every time you dequeue, you actually have to return back two values, the front and the rear. So yes, you are turning here the item, but then it means that you need to adjust and add another class here. So you need here front pointer and rear pointer, and you need to take when is the constructor here. Yes, okay, and then so when do you think, first of all, I would also like you to, yeah, so first, as you have seen, when we dequeue, let me try to remove the portion here. When we try to dequeue, what do we do to the front?
Increment it.
Okay, but are you aware that there is certain condition that the front pointer will even, so there is certain condition that this rear actually will not be here. So the front will keep dequeuing, and then if you try to enqueue, you find sometimes that the rear pointer become here, and sometimes the front pointer become here. Okay, and then you cannot keep incrementing the front to the end. You have to make sure that it doesn't exceed the maximum size of the queue. How you can do that? So the only way is to also do something similar to what you have done here with the models. So somehow you managed to get everything in a good condition, except that um, when we make sure that there is, when we dequeue all the items, we need to put back the pointers front and rear to -1 and -1. So we have to put some condition here to take care of that. Okay, but I would like you to, I mean, okay, so what you have done is actually correct, except that when you already dequeued everything, like here, I should be able to see -1 and -1 in both the front and rear, not only in one of them. So now, if you see here, your rear pointing is pointing to 4, but it shouldn't be. It should be, so it means that, okay, but I also want you to go down to your for loop. I'm interested in actually seeing inside your for loop here. Okay, you didn't use, I want you to use the rear pointer that you are sending to the item. And I want you to also put the rear, copy this printing also here. We would like to see if it is really printing correctly here. Put it under, after the, yes. No, I mean under here. So we can see both. Yeah, perfect. So I would like to highlight one thing to you. Do you see here?
Yeah.
So when you are, so it means that, okay, no, let me just explain this current condition. I know, I understand. This is the first time, and this is not so easy. I can understand that. Here is a rear pointer. Now you dequeued this, and then you are pointing to the next item. You dequeued it also, and you are pointing to here. And then you dequeued, and you are pointing to here. And then when you try to dequeue the last, before the last, it is here, you dequeue again, you will find your front pointer equal to the rear pointer. So when you are, this is the last item that you have. Okay, so once you dequeue, so it means that in your last item, the fifth one, you actually, the front is equal to the rear pointer. You can see here. Can you see this?
Yes. Yes.
So that is the condition that when you see it in the if statement, you should change to -1 and -1. Now, what is the condition that you use to reset back all the values to -1 and -1 inside the Dequeue? Check. So you do this, right? You say when the front equal 0, you reset both of them to -1 and -1, right?
Yes.
But actually, the condition is when both of them is equal. So you should put -1 and -1. So when the front equal rear, yes. Can you run again?
Wait, but shouldn't I put that like at the beginning, like before increment in front then, or?
I think yes, it should be before, yes. Something is not correct, right?
Yeah.
So what can we do?
Oh yeah, because it increments afterwards. Yeah. So that would turn the front into 0.
So my question now is that do we need to increment this if the front equal rear?
No.
So can we put maybe, so it means that if this is executed, then we don't need to don't need, yes, perfect. Yeah, so now it works fine. Yes, that's perfect. Okay, well done. So in the start, you managed to actually write similar code in almost the whole class. Am I right? And then now you adjusted everything in just less than 45 minutes, or even almost to half an hour only, right?
Yeah.
That's a good progress. So let me share my screen then. So Leo, we
Yes.
already have seen how to actually implement the static queue, which means that we need to take care of everything. We need to take care of the size. We need to take care of the Enqueue and Dequeue. We have to make functions for that. But there is also dynamic one, which means that it's similar to the linked list. We don't really need to take care of counting and incrementing the rear and front pointers. We don't need to do anything here. So the way to do that is to use both the linked list and the queue. And to do that, you have to import this Java util.queue. Okay, so this is a ready-made library for you that you are able to use. And this is a dynamic way. Of course, this is so much easier. Dynamic means that it's not fixed size. It can grow and shrink internally without you taking care of the size. So you just can, this is only the few lines that you can really need to use. So you have to define your queue like that. So this is a queue of strings, but be aware, you just don't use new queue. No, you have to use new linked list in this way. And then when you want to enqueue, you can enqueue this way, but just this is just a simple way. Let me share with you how actually we are implementing that. This is quite simple. In the linked list, we use add and remove. Okay, so what we have a look, so we have to close and open again.
Yep.